Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on LaTeX for Java developers. And so far, we've seen what LaTeX is, how to download it, and then why LaTeX commands, especially for writing math equations, why they're so popular. Even WYSIWYG applications such as Microsoft Word supports the LaTeX commands for symbols and equations in its math environment. And we said that the very first we interact with LaTeX, or basically we tell LaTeX what to do using LaTeX commands, right? And LaTeX commands are just a text that starts with a backslash, and then it has some options in a square bracket, and it has arguments, right? Each argument is inside one pair of curly braces, and we saw examples of how to create this .txt, how to feed it to the PDF LaTeX, for example, which is one of the typesetters that come with the LaTeX packages. And then this can create the PDF. And then now let's look at what is our general idea for implementing LaTeX in Java, or basically how we want to interface with Java. So we want to start with a low level API, and then around that we're going to build a higher level API, right? So the idea here is that first we create a class called LaTeX renderer. So basically this LaTeX renderer provides a simple, very simple API to add text to our document, and then create basically the text file, .tex file, and it also takes care of rendering it. In other words, it takes care of feeding it to the LaTeX command line tool, and then which creates the PDF file, right? So when I say rendering the text file, it means we feed it to the LaTeX and it creates the PDF file. So LaTeX render is going to invoke the PDF LaTeX command line or typesetter by default. And again, if I fire up a terminal here, as I mentioned, you have to make sure that when you install the LaTeX package on your operating system, for example, Mac or Windows or Linux, you got to make sure that the text binary folder or directory is added to your path environment variable, so that the operating system can locate the PDF LaTeX or any typesetter from everywhere in the operating system, right? That's the whole meaning of the path environment variable. It's not, if you're not familiar with what path environment is, it's basically the path environment variable is a variable that holds the locations of some folders, some directories in your operating system. And the reason it's useful is that when you have a folder on the path environment variable, in this case, for example, TechBean, which means LaTeX binaries. So all the binaries of the PDF LaTeX, or basically of the LaTeX package. I installed MacTeX on the Mac operating system. When you install that, all the binaries are inside this TechBean, text binary folder, and this is added to my path environment variable. So the reason that that's a good thing is that then we don't need to use basically this command, right? So when we want to run some application from terminal or command line, we have to specify, we have to tell the operating system where its binary or its executable file is, right? But if the folder that is containing this binary, in this case it's TechBean, it's already inside the path, then we don't need to specify the absolute full path to that binary. We can just specify the name, because if I don't specify the full path, the operating system first tries to search for this binary inside the current directory. If it cannot find it, it tries to search into the path. So it searches all the folders or directories that are on the path environment variable. So it's always a good thing that when you install a executable command line application like PDF LaTeX, you got to make sure that it's also on your path environment. Similarly with Java, right? Java is, when you install JDK, you want to make sure that the bin directory of your JDK is on the path, so that when you just type Java, the operating system searches the current directory. It cannot find Java application, so it tries to search all the folders or directories that are on your path operating system. And you can always check if a application is on your path by using the which command on Mac and Linux. And if the operating system can find it, it tells you where it is. So, and then you you are sure that this application is executable from everywhere on your operating system. All right, so we can have a method to set the name of the typesetter. As I mentioned, LaTeX comes with different typesetters. For example, PDF LaTeX. PDF LaTeX is one of the typesetters, right? And when you have a text file, you can feed it to you can feed it to the PDF LaTeX typesetter using PDF LaTeX space the name of the text file, right? And PDF LaTeX accepts a couple of arguments, and I'll probably discuss a few of them in the future lectures, right? So it can accept arguments using the hyphen arguments, right? And the other one, for example, is ZLaTeX, right? It's another typesetter, and let me see if we can find anything LaTeX. Okay, you cannot find it, but you can basically ls. We can try to see, and then we feed it to the grep, and then we say anything that has tech in it. Or maybe so there are some or maybe anything that has LaTeX in it. Okay, so LaTeX, let me clean up the. So if you're not familiar with what grep is or what pipelining is, so basically when you run a command line application, in this case I'm running the ls, which is an executable command line application with this argument. So it tries to list all the files inside this folder, take bean. And then with pipelining, we feed the output of this command, which is some text, to the grep executable. And grep is just an executable for searching some text, right? So we say, okay, instead of printing the output of this result to the console, the terminal, feed that to the grep, and grep searches for a particular regex. In this case, I'm telling you just search for anything that has LaTeX in it. So AR LaTeX, BG5 plus LaTeX, BG5 plus PDF LaTeX, BG5 LaTeX, and then if we go down, CLZ LaTeX, for example, LaTeX is still a command itself, LaTeX to man, LaTeX def, LaTeX diff, for example, LaTeX MK, P LaTeX, PDF LaTeX, PDF CS LaTeX, PDF LaTeX dev, PS LaTeX. I believe this creates a PostScript file. PDF LaTeX creates a PDF file by default. And then SJIS LaTeX, for example, SJIS PDF LaTeX, UP LaTeX, UP LaTeX dev, Z LaTeX dev, and XH LaTeX. And again, you can search for what these typesetters are. So you can search for what Z LaTeX is, you can search for what PDF LaTeX is, you can search for what PS LaTeX is. But these are the typical typesetters that come with a PDF with the LaTeX package if you install MacTeX on your operating system. All right, so let's put this aside. So when we want to create a text file in Java, which is the job of this LaTeX renderer class, we have to specify the template of the document, right? This is what we discussed before, and we said that the very first thing that we need to do, we need to tell LaTeX what kind of template of document we're going to use, and that's specified by the document class command, right? So we can tell it it's an article, we can tell it it's a PowerPoint presentation or something like that. Or if you're familiar with writing scientific publications for different journals, like scientific journals, each scientific journal has its own LaTeX template, and that comes with something called the style file, right? So usually if you make it available, that style file, to your LaTeX, which you just copy and paste that style file into where your LaTeX directory, your LaTeX file is, this text file, right? You can specify it here as the document type, right? So different articles, different journals have different styles, and it may not be the same default article that comes with the LaTeX package, right? And then we said that there are something called the preamble, and preamble is anything that comes between the first line, which you specify the document class, and when you start the document, right? We said that the main text, the text of the document, goes between or goes inside a document environment. And the document environment or any environment in LaTeX starts with begin and the name of the environment. For example, if you want to write equations, you use begin equation, end equation, right? If you want to add a figure, you use begin figure, end figure, something like that. So you create an environment. That's the general idea of an environment in LaTeX, right? Content. So main document is between the inside the document environment, contains the elements of the main text. So raw text, equations, math environments, figure environments, inline equations, or display equation. When you put equation inside a math environment, LaTeX interprets this as a display mode, right? Equation in the display mode. And if you recall from our past lecture, we discussed what a display mode is, what the inline mode is. So if you don't if you write equation, what you don't put it inside the math environment, LaTeX interprets it as a inline equation, for example, right? So what is preamble? Preamble is anything that comes after your document class and before you begin the document environment. So preambles, the main use of preamble is defining packages. So telling LaTeX what package to use, right? Because I mean, LaTeX, when you run PDF LaTeX, it already has some packages, very limited number of packages built inside this. But then again, because PDF LaTeX is a modular platform and it uses a lot of packages, most likely we always need to use some packages to give LaTeX extra abilities, right? It's very similar to libraries in Java. When you write a Java code, you usually import some other libraries, add them to your Java class path so that you can use them. So, and then the other thing is that you can create new LaTeX commands. So LaTeX has a capability that we can, so let's say there are a few different commands that you always need to execute after each other. So you can define a new command that executes all those three commands, for example, at the same time. So sometimes it's easier to do it, and that's one of the powerful things about LaTeX, right? You can program it so that you don't need to copy and paste a lot of text, it's fully programmable, and that's very good. So it's not like just there are some very limited number of LaTeX commands and you should always use them. You can actually define new commands that use a combination of different tasks, right? And you can also, after you create a package using the use package command, again, just like any other command, use package command also can take some arguments or options and then the argument, right? Typically packages take only one argument, which is the name of the package. So here for a package, the argument here is just the argument is just the name of the package, right? The argument for a package is just the name of the package. But then there are some options for maybe configuring the package. So options here for package is the options that package can have, which is configuring the package, right? But sometimes there are some extra configuration that we have to use other commands to add more configuration to that package. So after writing down the use package command, we can also have some command after that and before the begin document command to configure some packages. All right. So let's head to Eclipse and try to look at like this math package. So math package, the widely used package is AMS Math, which stands for American Math Society Math. So this is the math package from American Math Society, and also the symbols. So American Math Society AMS symbol SYMB, right? So you need the base math command and also the symbol package, right? So let's head to Eclipse. In Eclipse, I have this LaTeX tutorial. So far, we've seen 2 tutorials. So let's create a new folder and let's call this tutorial_3. And here I'm going to create just a plain text file, tutorial3.tex. This is our tag command. Okay, let me just, all right, that's fine. So I'm going to cancel this for now. So this is a plain text file, right? And we can start with the document class, and let's set the default font size to 10 pt, and then let's say it's article, right? And then eventually we need to begin document and end document, right? This is what we have to do so that LaTeX knows where our document begins and where it ends. And inside this, let's add some raw text or plain text. Hello world, for example. This is raw text, and we just save this, and then we open a LaTeX terminal inside this folder by selecting that file and creating a new terminal. So if I hit right ls, it tells me that I'm inside, or I can also do pwd, print working directory, and tells me I'm inside this tutorial 3, which is correct. And then pdf latex tutorial3.tex. We feed this very simple text file to pdf latex, and it outputs a PDF for us, right? We've seen this before, but now let's try to create a math environment. So again, it's an environment, so it starts with begin and ends with end. And then in the environment, for it to be a specific environment, like a math environment, we have to give it the name of the environment. In this case, it's an equation. So we want to create a single equation, right? This is not multiple lines of equation. This is a single line of equation. And because it's defined in a math environment or equation environment, it's going to be in the display mode. So LaTeX is going to interpret this equation in the display mode. So the equation is going to be on a single line. There is no other text is going to be allowed on that single line. So the text is either above the equation line or below it. That's the meaning of the display mode for math. So let's just say beta equals f of zeta, right? So if I run, okay, maybe let me also clean this folder, delete, okay, let's just have the tag. So PDF LaTeX and tutorial 3, and output written on tutorial 3. So let's refresh this and let's look at this. As you can see, the equation is there. And LaTeX was able to basically render this in the display mode. And as you can see, by default, it's numbered. And this numbering is very useful later on when we want to refer to this. And that's one of the weaknesses of Microsoft Word, for example. So in Microsoft Word, you can manually number them, but then later on, if you want to refer to them, so first of all, if I try to write some number to number this equation, it's going to change it to the inline mode, not display mode. So if try to change it to display mode, the text goes on the next line. That's just because the display mode is defined such that there is no text is allowed, right? So if I try to again write some text here, it changes this to inline mode, not display mode, which is painful. So typically what I do, I try to put my equations inside a table environment. So I go to insert table, I create a 2-row table or 2-column table. Here is my equation, right? And then because when you have a table, basically each entry of the table is interpreted separately in Microsoft Word. So if I add a equation here, right? And now it's not adding this text here is not messing up the display mode of this part. And later, if I want to remove this, basically the borders, I just go here and say no border. So that's something like that. Obviously, in order to align the number with the center, I can go to the layout, and then let me just and then let's see, table design or layout, and it has alignment. I can say everything is center aligned. And now this is typically what I do in Word, and really there is no other way to do it in Word, right? I mean, there are some plugins that allow you to add numbers, but adding numbers this is a very simple solution, and that's the most easiest way, and I think that's what I always use in Microsoft Word. But then the problem is that later on, if you want to refer to this equation with this number, you have to write look at equation 3, for example, right? And let's say down the road you add another equation and then the numbering changes and this becomes 4, and you have to manually change this numbering. And then you have to also manually go and change all the numberings that are referring to this equation right here. And that's very painful things, and that's one of the powers of LaTeX. LaTeX automatically takes care of all this stuff for you, so you really don't need to worry about numbering equations, citing publications, adding bibliography. LaTeX takes care of everything for you. You only need to focus on writing your document, right? So even WYSIWYG word processors like Microsoft Word, even though they're very strong in terms of providing like very easy to use interface, you can drag and drop a image, and then really in a nice way you can basically edit that image or whatever. The problem is that in scientific writings you always have this kind of citations, you may have lots of equations and whatever, and then you want to refer those equations, and then if down the road you edit some pages, add more equations, the numberings have to change, and all those equation numbering also, the ones that you have referred to in your main text also have to change. And also and then it becomes really painful to do it in Microsoft Word. It's possible, I'm not saying it's not impossible, but it's LaTeX takes care of all of that for you, so you don't need to worry about that. So I hope you enjoyed this lecture. In the next lecture, we looked at LaTeX renderer, start implementing it, and then we take it from there. I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.